Hello student, very good morning all of you. I hope you all are very happy, fine and healthy at home. So let us discuss today and the strength of organic bases. So far we have learned, because we are talking about the chapter number 1. The name of that chapter is the strength of organic acids and bases. So we have covered so far all the application or whatever thing required for acid strength that we all learned. So today we are going to start the remaining part, that is the strength of bases. We are talking about the strength of bases, right? Strength of bases, what does it mean? Bases, as we know that we have learned 3 theory regarding the bases or acids. Now here specifically I am going to talk about the bases. So according to as a Levy's base, third theory, if you remember, that is a modern theory. According to that theory, base is a substance which can donate the lone pair, that is known as a bases. Now according to that, let us see, suppose we have a B, is called as a base, and base can pick up the proton and we are going to get as a BH plus, that is a conjugate acid is formed. So what are the factor? What are the factor which affect the strength of basicity? Do you remember? The strength of basicity depend upon there are, I think, number of factors are there. Out of that, 1 mark question may appear in the exam. What type of the question lists the factor affecting the strength of basicity, and that time you must at least 1 mark question, so you must list or you should mention at least 2 factors, first and second, or maybe whatever you remember, you write down that 2 at least. 1, if you mention 1, you will get half mark, another one half means you will get as a full mark. So what are the factor? Because the derivation, everything, pKb values, all these derivation we have seen, and this derivation is not in our not going to appear in the exam, because that is an analytical part or physical part. Here in the organic chemistry, here we are going to consider only what do you mean by the pK value, how it decided the acidity and the basicity of the organic molecule. So here normally we are talking about the bases, means the according to as a Levy's bases. Here number 1 factor affecting the strength of bases. Let us see here, factor affecting the strength of bases. Factor affecting strength of bases. Number 1 factor, that is called as the availability of the lone pair. Look at here, base. Generally the bases are in terms of the organic chemistry, those organic compounds containing nitrogen atom are basic in nature, because the nitrogen atom containing as a lone pair on it can be donated very easily, and therefore it act as a basis, and therefore first factor the availability of the lone pair, the availability of lone pair, that is the first factor which affect the lone pair of electron, which affect the strength of bases. So what does it mean? Availability of lone pair means what? For example, let me give you one simplest example. Here suppose we have a OH minus here and the water molecule H2, right? Water molecule is a neutral molecule, or which containing as a lone pair on it, 2 lone pairs are there. What do you think? According to you, which one is a more basic in nature? Here, general statement you remember, those species carrying negative charge are more basic than the neutral molecule. Here water, everybody knows that water is a neutral molecule and OH minus is a negative charge, and therefore here hydroxy is a more basic than the water molecules. So that is the meaning of that availability of the lone pair. If the availability of the lone pair is readily available, they are the strength of basicity goes on increasing. So that is the first factor that affecting the strength of base. Now moving toward the next factor that is related to as a B, right? The next one, the electronegativity of base. Second factor will be the electronegativity of B. Here remember, second factor, the electronegativity of B. B means here we are considering as a B as an atom or the base. If here you in general remember, as the electronegativity goes on increasing, basicity goes on decreasing. Remember what I said just now, if the electronegativity goes on increasing, basicity goes on decreasing. What is, okay, again let me give you one example here. Suppose you have this one simplest molecule, you know that one is a ammonia molecule and another one is a water molecule. Now as we know that here the according to you, which one is more basic in nature? Right, ammonia is more basic than the water molecule, right? Ammonia is more basic than the, because if you know that, if you look at the electronegativity as we are moving across the period, if you remember the second row of the modern long form of the periodic table, there the electronegativity goes on increasing as we are moving from left hand side to the right hand side. Fluorine is the highest electronegative element. If you look at first one is a lithium, beryllium, boron, carbon, nitrogen, oxygen. After nitrogen, oxygen is there on a right hand side. Which one is more electronegative in nature? Here is a oxygen atom is more electronegative in nature than the nitrogen atom. Oxygen atom is more electronegative than nitrogen atom. And then what happened? What happened that oxygen atom has a great ability to pull the electron or to attract the electron or to hold the electron on that atom is greatly. But if nitrogen atom is less electronegative, whatever lone pair present on it, it is readily available for donation, and therefore the electronegativity goes on increasing, basicity goes on decreasing. That is the one sentence you remember here. Now let us move on to the third factor. What is that third factor? Is the structural effect of base. Then next one, the structural effect of base. Structural effect of B. Here the structural effect of B means, here just remember that structural effect of B means what type of the structure that B atom has. Suppose there are the, and as we know that plus I inductive effect and the plus R inductive effect. Here in general remember plus I and plus R, similarly minus I and minus R. What do you think? Suppose here those the structural effect means B having minus I and minus R effect. If there is a electron withdrawing group present, they exerts minus I inductive effect as well as minus R inductive effect, and if they are present, that decreases the basicity. Remember, if the minus I inductive effect and the minus R inductive effect are present in that organic compound, they decreases the basicity of that, and vice versa, or whereas plus I inductive effect and the plus R inductive effect, they increases the basicity of that organic basis. That is the thing you have to remember here. Now the fourth point, what is that fourth point to discuss here? The fourth point will be the fourth factor is the stability of the conjugate base. Fourth one is the stability of stability of conjugate acid here. Remember, this is a conjugate acid here, and if the stability of the conjugate acid means what? If the stability of the conjugate acid goes on increasing, the basicity also goes on increasing. That is the thing you must remember as far as this the stability of the conjugate acid is concerned. And now is the last factor, that is the fifth factor that is called as the nature of solvent. Last one is the nature of solvent. And in nature of solvent, and as we know that solvent has a two nature. They are present in two types. One is called as a polar solvent. Next another one is called as a non-polar solvent. If the non-polar solvents are there, they increases the basicity, whereas polar solvent decreases the basicity. The role playing by the solvent is a very vital or very important one, because the polar solvent, what they do, they solvate that basis, and therefore that non-bonding electron pair are not available for donation, and due to this reason the basicity decreases. In non-polar solvent, such type of the solvated base are not present over there, and that's why they are the more basic in nature, or that basic strength goes on increasing. These are the 5 factors which greatly affect the strength of basicity. This about the factor affecting the strength of basis that we have seen. Now moving toward the application part now. By using these are the factor, we are going to learn why some of the bases are stronger over the other one, or why some of the bases are weaker than the other one. So let us discuss by considering these all factor take into consideration, and I am trying to explain the strength of the following bases. Before that, as we know that organic bases further divided into as a 3 type. Organic bases or organic bases further divided into the 3 type. Do you remember, do you know what are the types of the organic bases? Here mainly there are the 3 types of the organic bases. Let me tell you. First one is a aliphatic basis, right? Aliphatic basis. First one aliphatic and the aromatic. At the from the 11th standard you are learning that aliphatic and the aromatic, and we are performing as a one test in the laboratory chemical method to identify whether the following compound is aliphatic in nature or the aromatic in nature. Which test you are performing in the laboratory, taking as a small amount of the substance on a wire gauze, putting on the burner. If sooty flame comes, you are saying that aromatic compound is present. If not, that is a saturated, means aliphatic compounds are there. Now that aliphatic, or it is a acyclic compound or open chain compound, or maybe as a cyclic, so that is there. And now second one is called as a aromatic basis. Second one is a aromatic basis, and third one is known as a heterocyclic basis. Heterocyclic basis, right? These are the 3 main type of the organic bases: aliphatic basis, aromatic basis, and the heterocyclic basis. Aromatic basis means what? Aromatic compound has some fixed criteria, and if those organic compound fulfilling that criteria, and then that type of the compound only as aromatic. Rest of the compound you can call it as aliphatic in nature, right? Aromatic compound, there must be cyclic compound, that is the first criteria. Second one is a fully conjugated. Conjugated means what? Carbon carbon double bond gets separated by the single bond, should be in alternative in nature. If they are present nearer to each other, that type of the compound is not the aromatic. They should be fully conjugated, means alternative carbon carbon double bond and the single bond. And the third criteria, the molecule must be the planar in nature. When the carbon carbon double bond comes, that molecule becomes as a planar, means planar, cyclic and fully conjugated and obeys the 4n plus 2 pi electron, that is a Huckel's rule. That compounds are called as aromatic, and these are called as aromatic bases, right? So the 4n plus 2 pi electrons. And now is a heterocyclic basis. Heterocyclic means basis means what? One of the carbon atom in an organic compound get replaced by the heteroatom. Heteroatom may be oxygen, nitrogen or sulfur. Few elements are there, they can capable of exchanging that cycle, and therefore that type of the basis is called as a heterocyclic basis. Now this all about the aliphatic basis, aromatic basis and the heterocyclic basis. Now we are going to learn one by one. That is the first one, we are going to learn aliphatic basis. What does it mean? So that let us see here aliphatic basis. First one, so we are talking about first one is a aliphatic basis. So here we are going to learn some of the applications of aliphatic. Generally here, suppose as a secondary amine is more basic than, say, let us see here the application may be as like the, our question may be like this: secondary amines is more basic than primary and tertiary amines. Explain. So here amines explain. Secondary amine, that type of the question may appear, or that you can consider it is the first application of the this aliphatic basis. Now let us see here. I am taking some of the examples. Suppose I have this one. Everybody knows that this structure, right? What is the name of this compound? The name of this compound is ammonia, right? This is a ammonia. Now second one I am writing here R NH2. What is it? The R, there is a NH2 group, it is called as a amine. Amines means what? The organic compound having as a general formula R NH2 is known as amines, where R may be as alkyl or the aryl group. Now this we can call it as a primary, 1:0, it is called as a primary, or you can draw here R2NH, it is known as a secondary amines, and third tertiary amine is R3N, this is known as a tertiary amine. These are the amines. If you look at here, I am changing, suppose R, let it be, suppose we know that, suppose NH3 amine, I am taking R is equal to as a methyl group here, CS3 NH2, that is a methyl amine. R2 means suppose as CS3, then NH, then CS3, this is called as a dimethyl amine, that is a secondary amine. Primary amine, this is a 0:0, that is ammonia you can call it, and all the three hydrogen atom get replaced by methyl group, that is known as a tertiary amines, right? This is a tertiary amine. Now as at the beginning what are the factor? If plus I inductive effect, that increases the basicity, as we know that. And here remember, I am writing as some of the pKb value, pKb values. As we remember, if the pKb values goes on decreasing, basicity goes on increasing. That is the criteria, or that is the general guideline you must remember. Now here pK value of this ammonia, I think approximately 4.75. Here it having as I think 3.36, here 3.20, and this one I think 4.20. These are the sum of the pKb values. If you observe these pKb value carefully, what do you see? Which one is the lowest one? You see here the secondary amine, the pKb value is the lowest. It means that this one is the strongest one. If the strength of this basis is measured or determined in case of the aqueous solution, then and then that follows which one is the strongest base. Then there the basicity order should be secondary is greater than primary, then tertiary, and then last one is a NH3. That is a stability. Means secondary amine, or what we can call it as a dimethylamine, is the strongest base because it has a base pKb value is less as compared to as a dash if it is aqueous. If the what we can call it as a if this basicity is measured in a gaseous phase, what do you observe there? The tertiary amine is a greater than secondary than the primary than the NH3. That is in the gaseous order. The order of basicity should be tertiary. Why? Because look at here, and here methyl group exerts the plus I inductive effect or shows plus I inductive effect. Here plus I inductive effect, here also is a plus I inductive effect. There are 3 methyl groups are there. They shows plus I inductive effect, or the magnitude of that plus I inductive effect is greater in the tertiary amine, and therefore in the gas phases this type of the basicity order should be like this: tertiary, then secondary, then primary, then the ammonia. But in a aqueous solution, like as a water solution, what is happening? The secondary amine found to be strongest base among this. Why? The reason behind it, the secondary in a aqueous medium, what is happening after that? Suppose as a secondary amine, here I am writing R, N, here is a R, then H positive charge is there. This is a secondary amine, get solvated with that water molecule. Here is a O, H and H, and tertiary amine, we know that there are the 3 R groups are there, R, and here only 1 proton it can pick up and form as a conjugate acid, and that conjugate acid is stabilized through water, through hydrogen bonding, that type of the hydrogen bonding, or this is stabilized due to the solvated of that via hydrogen bonding, and therefore this one is the strongest one, because not only the basicity of this amine not only decided by the plus I effect alone, but there is a other factor like as a strength of that hydrogen, solvation of that molecule, and therefore this one is the strongest one. This is about the first what we can call it as a first application of this. Now let us move on to the second application of basis, or here maybe as a 1, 2, 3 all these applications. Here suppose as a methylamine is stronger than the, or what we can call it as a secondary amine, second application, secondary amine is a stronger base than primary amine. Explain our tertiary amine. This type of the thing we already learned here, why they are more stable, because just now we have seen in a secondary amine there are the plus I inductivity. Let us see as a primary amine, or we can call it another way of this one, dimethylamine is a stronger base than methylamine. Explain, right? Explain. How do you explain this? The answer of this question is very simple. You can write here as a, and what is our first thing to do? First thing, you must draw the structure of the organic molecules, right? So dimethylamine, everybody knows that the structure of dimethylamine, NH, and this one. This is the structure of dimethylamine, right? Which containing as a nitrogen. And methylamine has a structure, this one, CH3, NH2. And what once you draw this structure, what you have to find out? Find out whether there is a plus I inductive effect is present or minus I. Look at there is a methyl group. There are two methyl groups, so they show plus I inductive effect. Here is only one methyl group. So the on the basis of plus I inductive effect, you can explain it, because the magnitude of plus I inductive effect in a dimethylamine is a greater as compared to the methylamine. Hence, the dimethylamine is a stronger as compared to the methylamine. I think this is the second application. Third, fourth, fifth are remaining application. We will see next time. I think let us stop today here. Thank you. Have a nice day.